1000 to 1250 and 1300 to 1500 nanometer. However, certain range it will not allow. There is a inhibited spontaneous emission. And second one, that is strong localization of photons. So if there is a periodic structure, it is having inhibited spontaneous emission. If suppose I am going to break the periodicity, I am going to introduce the defect by the time, there is the possibility I can confine, I can control the no propagation inside the periodic structure. It is the concept of Sajid John, that is strong localization of photon. Very simple. That is the periodic structure. It will not allow certain wavelength. And if I am going to remove the periodicity, by the time certain range of wavelength or one mode will travel inside the structure. That is called strong localization of the photon. They met together in 1987 on conference at Canada. At the same year, Electronics published one paper and Sajid published one paper in the same journal. Both papers is having more than 15,000 citations at present. Only one paper, it has more than 15,000 citations. This is about the concept. Let's see in one by one what actually. So what are the types of photonic crystals? Photonic crystals, it is a periodic structure in 1, 2 and 3 dimensions. So here you can see there is red in color and yellow in color. It denotes the refractive index N1. It represents the refractive index N2. The variation of refractive index is only one direction, hence it is called as the one-dimensional photonic crystal. Similarly, in the case of two-dimensional photonic crystal, you can see N1, N2, N1, N2. There are two different directions. The N1 refractive index value or dielectric constant value is changed. Hence, it is called as the two-dimensional photonic crystal. At last, you can see there are three directions: X, Y, Z. All the three directions, the refractive index is varying. In optical, in photonics, the refractive index or dielectric constant is most important. If as your student as well as the members is there, if anybody is going to talk about above 1 terahertz, you must be very keen about that refractive index or dielectric constant. In the case of microwave applications, dielectric constant. In the case of optical communication, we are related refractive index, nothing different. Square root of dielectric constant is equal to refractive index. Both are same. Square root of dielectric constant is equal to refractive index. The thing is, if the refractive index alone is going to confine the light signal which is going to travel within the structure. That's all. So it is about one dimensional, two dimensional, and three dimensional. So among three categories, if anybody is interested to start a research, please pay attention. Here, the two-dimensional photonic crystal is the most interesting one. Why? Because there is the possibility to fabricate the device. I stated earlier the chip for photonic crystal in terms of micrometer. The chip for photonic crystal in terms of micrometer. Suppose if you wanted to work in IoT-based project in agriculture applications, we need a sensor to sense the humidity or any other perspective in soil or water. The size of the sensor is very, very small, very, very small. That's what we are talking about. If it is inside our body, it can sense what is our blood flow in our body, whether our lungs are functioning properly or not. As it is here, there are many materials are already available in order to support the human body. So the future is also predicted in such a way that recently we are having many sensors for external applications, but the research work is progressing significantly to realize to devise the sensor for wearable implantable applications. Okay, fine. Among three categories, 1, 2, and 3 three types of photonic crystal, two-dimensional photonic crystal is the most interesting because of easy fabrication and simple structure. We can easily vary N1, N2. That is the refractive index 1 and refractive index 2. And high confinement of light, that is light intensity, that we are giving 1 milliwatt of input power, we can get at least 0.98 milliwatt of output power. The loss is very, very minimal. That's about the confinement. And second one, the light signal we can easily control and we can easily calculate the photonic band gap. Let's see what actually is the photonic band gap. If anybody is interested to start your research area in this in this photonic crystal, you can start, you can note it down all the details. It will be useful for you to start your career and you can extend all the possibility in this area. And based on my experience, among three categories, two-dimensional photonic crystal, almost 95% of the researchers doing research in two-dimensional photonic crystal alone because of this advantage. Even with IISc Bangalore, IISc Bangalore, INEP is there. From INEP, it is possible to fabricate. Just to see here, very, very smaller, in the range of kilometer range, it is possible to fabricate in India. There is a two labs there from INEP, that is Indian Nano Electronics User Program, INEP. One is at IISc Bangalore, one more is IIT Bombay. If anybody interested, including PG student, can also join. Teachers, we can also join to fabricate once we have developed this system. So that is also possible. So better you can take two-dimensional photonic crystal for your applications. And it is actually derived from nature. It is actually derived from nature. You can see there are two types. Lattice, we can consider many kinds of lattice. Lattice is nothing but, don't worry, I can share it with you. If anybody needs this material, I can share it. There is no problem. Please listen. Any doubt, please you can ask. See, it is like our nature. Lattice is nothing but arrangement of either the atoms or molecular pillar or membranes. Primarily, two things are there. One is square lattice. Second one is a triangular lattice. Nothing. The arrangement of membranes or pillar or rod. Here, from square or triangle, two varieties. One is membrane cores, second one is TP edged pillars. It is about membrane cores, it is TP edged pillars. So, technically it is called, in photonic crystal, technically it is called, it is membrane core like honeycomb. You can see here, we have already seen that honeycomb, how it will be there. It's called membrane core. Second one, we can see that comb, bottom layer is connected. However, there is small kind of pillars or rods will be there. That is TP pillar. Concept is very easy. There is a reason it will be implemented for real time application. So, two varieties. And how the polarization of light signal? Whether will it support both TE or TM signal or both TEM signal? Yes, we have categorized. If it is membrane hole type, it is responsible to support TM polarized signal where the electric field will travel along the axis, the magnetic field will travel perpendicular to the fiber axis, perpendicular to the propagation axis. That is about TM. Alternatively, for TP pillars will support TE polarization. Alternate version, electric field will travel along the axis, magnetic field will travel perpendicular to the axis. So, if anybody ready to select, I am going to work with membrane code, ensure that the TM polarization is your input source signal. And it is the fabricated structure, one-dimensional photonic crystal, two-dimensional photonic crystal, and three-dimensional photonic crystal. Please keep in your mind, the size is very small. We cannot see such like that. Very smaller. However, the light signal is traveling perfectly within the structure. So it is one-dimensional, two-dimensional membrane core, and two-dimensional TP edge pillars. It is three-dimensional. In the case of three-dimensional, just they are fabricating the structure. Why? Because the complex much complexity. To ensure the a dielectric constant variation in 3 different dimensions really is very hectic in nature. So just they have fabricated the structure alone. However, very limited number of devices are proposed by using two-dimensional photonic crystal. You can ask the question, sir, okay, sir, what is the reason? One dimension is very easy. Two dimension is bit complex. Why there is no much research attempt is made in the case of one dimension in the sense? In the case of one dimension, to confirm the light signal is very difficult. So as the refractive index variation is occurred only one direction, if there is any scattering is occurred the other direction, it is very difficult to control. If the bending losses is keep on increasing the alternate direction, the reflection light is keep on increasing the alternate direction, by the time it's very hard to control the propagation of light in the case of one-dimensional photonic crystals based optical devices, SR, as well as other miniaturized devices. That is the reason why the scientists are very keen. Even in Silicon Valley, why they are very keen in 2D PCs? Because of the confinement and control. See, this is other one, the 2-dimension and 3-dimension, some of the structures. Actually, it is derived from the nature. Already we have seen there is cone and honeycomb, right? I think you would have seen, I don't think so, but the student saw this metallic repeater. Whoever from my childhood age just played with this metallic repeater. Next things, you can see two different colors. Yellow and yellow. From that they have identified. And second one, C mouse, you can see this is a schematic, like honeycomb, that's membrane cone based type. And 3-dimensional photonic crystal, just you catch the butterfly and take a scoping, you see there will be many layers will be there. From that only, just they have predicted that is photonic crystal concept. And you can see here there is some stone and peacock feather and other nature based which gives the concept of photonic crystal. Actually, when one domain will be succeed in the sense that should be highly reliable. Second one, you should derive from the nature. Why it's supposed to be derived from the nature in the sense? It's very easy to follow from the nature. That's the reason behind people are giving more attention. Even in nanoelectronics, it is also derived from the nature. Even in nanophotonics, it is also derived from the nature. Now let's come back to differentiate the photonic crystal actually the semiconductor or electronics and photonics. Basically, in the case of electronics, it is periodic array of atoms. It's basically we are discussing with atoms. And here we are talking about periodic variation of dielectric constant. Please, young engineers and teachers, keep in your mind square root of dielectric constant is equal to refractive index. In the optical communication, refractive index is going to have much significance. Why? Because the photon velocity is directly proportional to the refractive index. Okay. And next one, here semiconductor, it is atomic length scale. Here we are talking about wavelength. Now to differentiate, and it is natural structures, it is artificial structures. In semiconductor, it's control of electron flow, here control of electromagnetic wave propagation inside the periodic structure. It is very older one. It is well practiced. We in day-to-day life we are using nanometer based device in our hand. However, it is new frontier. Very limited structure is fabricated and characteristics. Still, it is not in our hand to enjoy the photonic crystal. But by thinking about the advanced technologies, it may come into our hand by 2030s. Here, like PC, there are three mode, band, and band. Photonic band gap. Photonic band gap is otherwise called as the strong inhibited spontaneous emission. That is called photonic band gap. Nothing. In a periodic structure, only any one of the wavelength is going to travel inside the structure. That is called mode. If the group of wavelength is going to travel, that is called band. Group of non-propagated wavelength, it is called photonic band gap. Here you can get clear picture about it. In this structure, it is actually the band diagram. Basically, technically it is called as the band diagram. All are simulated results. Okay, so it is a band diagram. Generally, band diagram gives propagation, wavelength propagation within the periodic structure. In order to generate this band diagram, we have accounted, along with my scholar, we have accounted 3 cross 3 lattice. There is a circular rod is selected in order to enhance the filling fraction. That is a technical term. Filling fraction is also required to increase the speed and performance. So 3 cross 3 square lattice is considered. Corresponding below, if we calculate the structure is periodic structure, if we have estimated the band diagram for smallest area which is equal to the entire area, so it is the smallest Brillouin zone area. So we have calculated PBG for 3 cross 3 lattice. Okay, here there are 2 modes. One is TE mode, it indicates blue in color. TM mode, it indicates red in color. It is deeply etched pillars or rod type, hence it is responsible for TE mode. Hence there is the PPG for TE polarization. Let's come back to our discussion. In the structure, if there is only one wavelength of the light, that is called mode. Group of wavelength of the light, it is called band. The non-allowed wavelength of light, the non-allowed light signal, it is called photonic band gap, which means that in the periodic structure, certain range, the signal will not allow to propagate. All the input signal is back, where the density of state is completely zero, which is light propagation is remaining zero. That is called inhibited spontaneous emission. So in this range, the range is calculated from 1241 nanometer to 1830 nanometer. The light signal will not enter into it. If, coming back to Sajid concept, I am going to break the periodicity. What will be happening if I am going to break the periodicity? By the time the light signal will be allowed within the structure, within the EPG. That is our goal. First thing, to identify photonic band gap for our operating wavelength region. Second, introduce the defects. Let's see one by one. Introduce the defect. Thereby, a mode will be permitted, will be allowed to travel within the PBG range according to our defects. So, the photonic band gap is depends upon the 3 important factors. So, it is a pillar type structure. First one is dielectric constant or refractive index or permittivity, and second one is the lattice constant, distance between 2 holes or distance between 2 pillars. Third one, radius of the rod or radius of the pillar. Okay, so based on the 3 structural parameters, the size of the photonic band gap is varying. So by having this periodic structure, we have accounted PBG. Now we wanted to break the PBG. How it is possible? It is possible by introducing the defect. Defect in the sense, I am going to break the periodicity. How? There are 3 possibilities: point defect, line defect, and surface defect. This is the technological name: point, line, surface defect. First one, point defect. In the periodic array of pillars, only one rod or only one pillar, we are going to vary either dielectric constant or lattice constant or radius of the rod. That is called actually the line defect, point defect. Or we are going to alter the structure parameter in a row. It is called as the line defect. Or at the edge, either we are going to vary the dielectric constant, lattice constant, radius of the edge rods is called as your surface defect. So by incorporating, by creating the defects, please keep in your mind, you can increase, you can use either line defect or point defect. Based on my experience, line and point defect will be the right option. Surface defect I never utilized. However, by combining, by giving input from one device to the another device, By the time the surface defect may be utilized, however, it will not be much impact while introducing the defects. So now you got clear about what is PPG. What will be happen if you are going to break the periodicity? Listen, this is the structure, right? It is a square lattice-based structure. It is the PPG and it is inhibited spontaneous emission, which means that I have created the structure and at certain wavelength range, you can see the signal is not allowed inside it. The signal is not allowed inside it. Second one, introducing the point effect. Here the point effect is nothing but the center of the rod is removed. The center of the rod is removed. What will be happening? There is some range of wavelength is broken. So in this range, you can see the frequency from 0.31 to 0.44. 0.44, the wavelength, I mean, there is a PBG, photonic bandgap, inhibited spontaneous emission, where the density of state is 0. So I have introduced one point effect. What will be happening? Near to 0.4, the PBG is broken into 2, and one more is propagating inside it. So based upon the defect introduced in the periodic structure, the more propagation, the more velocity, density of the state, spontaneous emission level will be varied. Second one, just I have removed the entire row. By the time you can see, the PPG is completely broken and the mode is propagating inside the structure. It is called strong localization of the photon. It is the concept of your Sajiv job. So inhibited spontaneous emission is the concept of Elliott group. After breaking the periodicity, the mode will be propagated inside the structure. It is called strong localization of the photons. This is the two important concept is having photonic crystals. Here you can just see that. So this is the periodic structure. You see here from 0.2 to 0.375, the transmission, just we apply the input signal, I need to get at least some output. However, because of strong inhibited spontaneous emission, all the signal is reflected back to the input source. So what will be happening? There is no output. So this range, the output signal is 0, though I have the input signal. And secondly, you see here the center rod is removed and there is the refractive index variation. By the way, what will be happen? You see here there is some transmission at 0.27 and there is some output at 0.38. It is actually strong localization of the photon, which means that I have broken the periodicity. Because of the periodicity, non-periodicity, it allows to propagate two modes. So this transmission, this frequency will depends upon the structural parameter as I have mentioned. One is dielectric constant, second one is the radius of the rod, and third one is the lattice constant. Here, it is actually called defect engineering. This concept is called as the defect engineering. How we are the defect? Based upon the defect, the output power, the output transmission will be varied. The frequency will be varied. As it is nanoelectronics, as it is nanophotonics, still now there is no proper formula related to the normalized output power and the operating wavelength with respect to the input parameters. There are three input parameters. Still, extensive research is progressing in order to correlate between structural parameter and the output performance. For the purpose only, recent research is pay attention about deep learning and machine learning. I am going to use these structural parameters. If I am using value of A, what may be my resonant wavelength, what may be my output power. If I am using value B, what about output power, what about output wavelength. So it is very, very interesting, very quickest area for your research. If you are very clear about deep learning and machine learning algorithm, if you know this concept, in my point of view, 1.5 years is highly sufficient to complete your research. Already, my scholars started work to identify output value with respect to the input value. This is about photonic research. And this is essential to calculate the PPG range. Typically, the PPG range is TE-PPG, TM-PPG and combined PPG. We wanted to know, I have decided to work from 750 nanometer to 1500 nanometer. So, what is the value? What is the delta value we need to select? Delta in the sense refractive index, N2 minus N1 minus N2. What is the lattice constant I have to choose? What is the radius of the rod that I have to choose? That is the most important one. To identify the structural parameters. It's not so easy. In fact, you can select from your literature, nothing wrong. But we are supposed to know how they have selected the structural parameter value for their application. So that is possible in the case of CAD map. In my tool, which I am using RSA, where is the provision to simulate and get gap map, it gives the variation of PPG range with respect to the structural parameter values. And there are many analytical methods are available, plane wave expansion method, FDTD method, and there are 10 more methods are available. Here, our applications, we have predominantly used PWE method and FDTD method. Here, in the case of FDTD method, one more question will be asked. There is 2D FDTD and 3D FDTD method. In fact, in antenna people is also working with FDTD, but in optical is also they are working with FDTD. So both 2D and 3D almost giving a similar performance. This is another one more area. We spend a lot of time in order to match the result from 2D FDTD and the 3D FDTD. The thing is, it will take the simulation to get one result. It will take 1 week or 2 weeks with 24 hours working day. It will take 2 weeks to get one response with higher level of system. That's the reason. So I advise the young researcher, if you are interested, to select 2D FDTD method instead of 3D FDTD method. If the question is asked why, what's the difference between 2D and 3D FDTD method in the sense, the performance level is almost equal. Almost equal. However, 3D FDTD method, it gives much complexity, and it will take mammoth amount of time to derive the output. So this is the difference between PWE and FDTD method. Here, PWE method was predominantly used to get plane-based photonic band gaps, mode and band gaps. Alternatively, the FDTD method, we can get the normalized output power. Otherwise, I can say this response is obtained by FDTD method. This response is obtained by plane wave expansion method. This is the method. And you know very well, photonic crystal. It is ability to obtain photonic crystal with ultra-high refractive index. Is anybody working with optical communication? Please keep in your mind that the refractive index should not be above 4. Refractive index should not above 4. Any material if you are considering, please keep in your mind that refractive N value should not greater than 4. If it is greater than 4, the velocity of light is equal to velocity of the electron. By the time what will be happen, the electron speed is also equal to the photon speed. By the time nanoelectronics is equal to nanophotonics. So please keep in your mind, don't go with above 4 refractive index. And next one, ability to control spontaneous emission in photonic crystal. Yes, by introducing the defect, it is also possible. By the defect engineering, I can control the output power and I can control the confinement. And novel environment for quantum mechanical light matter interaction, variety of micro nanophotonic sensors for IoT and for AI applications will be possible in photonic crystals. And another thing, easy to confirm the propagation of light as we stated, high speed of operation. There is no aging problem. In the case of optical lens phase sensor, we cannot ensure the output performance is remaining same from day 1 to year 10. But we can expect a similar performance from photonic sensor from day 1 to year 10. That is the problem. And lifespan is much higher, and tolerance to temperature fluctuation and low loss. And most interestingly, you see the size is much smaller, 100 to 1000 times smaller, very very small. At last, easy to integrate. We can connect one device to another device. And these are all the possible applications. Almost all kind of optical device we can design using photonic crystals. You can think about what is this adapter, channel adapter, all the devices are required for IoT application as well as to implement PX integrated circuits for artificial intelligence. Okay? It seems, what about the PIC? It seems layer 1 like 4 or months. You see here layer 1, you may have some 30 number of components, and layer 2, it is having some interconnection, having 30 different number of components. So it is predicted that within our 4 centimeter to 4 centimeter, we can keep the telecommunication sector. So once we enter into any one of the BSN office, you can see very big telecom sector office will be there. So within 4 × 4, once PAC is came into the picture, within your hand, the telecommunication box will be positioned. This is about PAC. So meanwhile, if you are having any questions, let me know. Next, let's talk about PLCs. These are all about basics. These are all about basics. If you are very clear in basics, that's all you can. Then imagination, creativity alone is enough. Is it okay? Are getting
Actually, I'm working on.
No. Some members will getting difficult to come and to ask the question. That's what I asked for. Please stand.
Yes, actually, I'm working on ED signal processing. So actually, you are acquiring the signals based on non-invasive method.
Sorry?
Actually, two methods are there. There's a non-invasive and invasive method.
Yes.
So actually, you are working on signals, and you are acquiring the signals through non-invasive method. But the scientists are suggesting that because of this non-invasive method, you are not getting the signals
Properly.
like so many disturbances are coming. So that's why you are suggesting invasive method when compared to non-invasive. So that's why you are suggesting directly the sensors are placing inside of the brain cells. So to reduce the disturbance, like environmental disturbances, like muscle artifacts, like that. So that's why is it I see about this photonic crystal. So is it suggestible for this non-invasive method?
Let's see the significance the photonic sensor is going to be implemented in our body. Okay, the material engineering, already they have joined together, they work with material engineering. That is, even a sensor is positioned inside our body, it will work longer life. That is the importance of photonic crystal. And it will not disturb our body. So once sensor is present, and it will not disturb any of our body movement. However, it will give right information to us, which in turn talk. Even we are wearing a smartwatch. What will be happening? Even your heartbeat you can get it, or if you are running, you can see what's your running step. Everything. Even if you are sleeping, whether you slept well, what about your strong sleep? Everything you can notify. Why? Because the sensor is positioned outside of our body. From the outside itself, we can identify. Once the sensor is positioned and monitor all the performance within the body, then doctors will find easiest way what is the actual problem. Nowadays, the I mean, once there is any uncertainty in the hospital, I mean, you know what will be happening. We are finding very difficult to identify what is the problem under. Even once some person will admit in the hospital, you will not get immediate reason. What is the reason behind it? What are the problems that he is facing? Whether there is a problem in heart, problem in some other issues. But once the sensor is positioned inside your body, they will collect the information very quickly, and there will be a lookup table. If they will compare with the lookup table, the reference table, and you can see the output. So problem 1, so on. So problem 2, it is problem 3. Next one, problem 1, what is the medicine? Problem 2, what is the medicine? Problem 3, what is the medicine? So the AI-based device will give medicine to all the patients. As far as madam concerned, sir, whether it is invasive or non-invasive. Invasive is possible for photonic sensor. The thing is, the size is very small. I am talking about in terms of micrometer. The size is very small, and the performance will not deteriorate. In my point of view, prediction definitely is possible. I have kind information. I have worked the sensor. However, still, photonic sensor is not implemented in the body to evaluate the performance. The problem is, as it is very tiny, very smaller, first thing to come to the signal, to get the signal itself is very challenging. So hopefully, as nowadays there are many advanced equipments came into the picture. In the case of medical application, it is also possible in future. Or you can also explore just at the end, you can try on sensor. In fact, we are also made attempt on sensor for biomedical application, biomedications. I mentioned about IT Bombay, ISC Bangalore. You can try to design a new chip, fabricate it, then calibrate it. Once fabricated and characterizes the performance, then it's not to implement. Let's see. But you need a comparison about the electronic sensor and the photonic sensor. If both is good, by the time there is the possibility to incorporate.
Like is it easy sir to place like a pacemaker or placing in?
Yes, that's what I was.
That's why is it okay to place it for photonic sensor or braces?
That is the concept beginning photonic based sensors to implement inside the body. But I think pacemaker is removed, right?
Some permanent pacemakers also now available.
Same material will be used. Right? Any other clarification?
So shall I give one suggestion?
Please.
Actually, you take in photonic side, crystal is available. Based on the crystal, you can collect the name of the sensor is called refractive index. Refractive index sensor. So based on that, you can calculate glucose level in the blood. So that is also going on research. So based on that sensor, you can do it. So either you take invoice method or non-invoice method.
Actually, non-invasive, that you are taking EEG signals with electrodes when you are taking a webcam.
But the problem is accepting the signal now, that will be very challenging. And you are placing inside our body, no, it will be very challenging.
Yes.
So that kind of materials you have to decide. Once you identify that kind of materials, it is very easy to insert in our body.
These are also trying about photonic crystal as well. So that's why I am thinking about whether it's going to form the brain cells.
No. That's about proper material. If you are having proper selection of the material, that will not affect your health as well as the brain activity. That is the protection is given. As sir has mentioned, optical sensor is directly related to the refractive index of the material. I am going to talk about that sensor. You will get slight information. What will be happen once the sensor is identified the value. That I am going to do. See, as far as medical sensor is concerned, both invasive and non-invasive, whether we are going to keep photonic sensor in a smartwatch or we are going to keep photonic sensor in our body. Let's identify that I am going to have some photonic sensor in my body to sense my heartbeat, my blood flow and glucose level, pressure level, anything, just your assumption. There are two things possibility. One is I can wear watch to monitor everything. Second one, I can implant in my body to monitor everything. First difficulty. If it is external, there is no problem, I can monitor everything. However, we cannot expect the accurate percentage. Alternatively, I can keep sensor inside my body. If I am keeping inside my body, the thing is to collect the data from the sensor is very challenging. So there are many technologies came to the picture. If you just make some big in the ground by 3 feet, just close the thing with your cell phone, make a call. Whether your cell phone will get the signal or not. Will get the signal? No. But if you think about the higher frequency 5G, there is a possibility. In 5G, there is a possibility. Even 3 feet, just to take a small thing and keep your cell phone, there is a possibility your cell phone will ring. Similarly, the optical sensor, the photonic sensor is the high frequency sensor. As it is the high frequency, higher wavelength, there is the possibility to penetrate the human body, which it may be connected. Though I am having the sensor inside my body, and I have a device, supporting device in my hand, because of the external activity, I will receive the signal from the sensor which I kept inside my body to my cell phone. That is the possibility. That is the possibility. How I am going to get the signal? That is the discussion. Here, there are two kinds of sensing mechanism in the case of photonic sensor. First one, homogeneous. Second one is the surface sensing. So, what is the surface sensing? Homogeneous in the sense. Homogeneous, you know very well that entire sensor will position inside the particle. If it is water sensor, I am going to keep the sensor inside the water. That is called homogeneous sensing. And surface sensing, very simple. Just I wanted to sense the water, like I want to measure the glucose in your blood. The water will be taken, just you take a small needle, just touch, and there is a needle will be there, and at the end you can see one touch, you can see what is your sugar level in your body. That is actually the surface sensing. Surface sensing in the sense, a small droplet of the particular particle will be touched, will be kept inside the sensor. Based on the lookup table, the output will be displayed. What is the sugar level, what is your pressure level. That is the two types of sensor, homogeneous sensing and surface sensing. For medical application, it is highly essential to have only surface sensing. Why? Because we cannot keep our sensor inside our blood to measure the blood level, to measure the glucose level. That is unethical and it's not at all possible. However, for practical application, we want to the salinity of seawater. What is the salt level of seawater? That is possible. Just we have a sensor. I can immerse sensor into the water and I can take the output. What is the salinity of the seawater? So there are two types of sensor. And in photonics, two varieties are there. One is wave-gate based sensor. Second one is ring resonator based sensor. The thing is, in the case of wave-gate based sensor, it requires slightly higher amount of sensing quality. If I wanted to sense water, if I wanted to sense blood glucose level in the blood, it requires more amount than the ring resonator based device. So, in my advice for medical application, if anybody interested, you are in position to select ring resonator based sensors. Why? Because it gives better performance because of multiple rounded inside the structure and it gives higher sensitivity, higher output level in wave-gate based sensor. So in my advice, I'll come back to that. Let me finish, I'll come back to that. In my advice, if you want to select at homogeneous, you can go with wave-gate based sensor. If your sensor is interested, if you are interested to select medical application, better you can select ring resonator based sensor. Next, okay. Now, sir, I have selected either homogeneous or surface sensing. Second, I have selected either wave-gate based sensor and ring resonator sensor. How can I get the output? If there is any variation in the glucose level, how the output is predicted? If there is any variation in the pressure level, how it is predicted? If there is any variation in any external parameter, how it is predicted? there are two possibilities. Firstly, refractive index variation, that is called resonant wavelength shift scheme. Second one, intensity variations. The thing is, optical sensor, photonic sensor has related refractive index. If the refractive index is varied, which in turn the output will be varied in two terms. One is the resonant wavelength, the operating wavelength will be shifted into either upwards or downwards. Second one, the intensity will be either increased or decreased by having. So generally, my glucose level is normal. By the time the resonant wavelength will be 50 nanometer. Next, glucose level is either increased or decreased, which is the corresponding delta value, refractive index value will be varied. Alternatively, what will be happening in the sense, either my resonant wavelength will be shifted into the higher wavelength or lower wavelength, or intensity may be reduced or increased. By identifying what is the range of resonant wavelength shift, what about the intensity reduction, I came to know that the display will give your sugar level, your pressure level, your temperature level, your refractive index level. So this is about photonic sensor. You see here, this is the transmitter. At the end you got some this is the transmitter. That is the optical laser signal. This is the photonic sensor. What we are discussing about, any kind, either homogeneous or surface, or it may be either waveguide based, or it may be ring resonator based. Actually, here we have decided ring resonator based. Second one, receiver. I mean, the light signal is coming here and it will be converted into the electric. And next one, as Madam is discussing, signal processing unit. Already there is some set of values required. It is there. So, what is the changes in the value? According to that, the output will be displayed. Whether it may be intensity may be displayed, intensity variation may be occur, or resonant shift may be occur at signal processing unit based on the variation of intensity and the resonant wavelength in the display. You can get what is the sugar level, what is the pressure level. And for your information, either the sensor may be followed any one mechanism, either resonant wavelength shift scheme or intensity variation scheme. These are the possibilities. Let's see one example. That way you can get identification. Here we made small atom. It is in photonic sensor journal. It is the salinity of the seawater. The attempt is made to check the salinity of seawater using photonic sensor. So we know very well that it is the refractive index. I mentioned earlier, refractive index, it is the parameter is primarily and most importantly required for photonic or optical sensor. Without that, it's very, very hard. So it is the refractive index. So for this, it is noticed that the salinity is increased, that is salinity of the sea water is increased. The refractive index of the water is also keep on increasing. And secondly, if the temperature of the water is increased, the refractive index is reduced. This is normally what will be happening. Seawater salt level is increased, which in the density of the water is keep on increasing, which in the refractive index is also keep on increasing. In the temperature, if you are increasing the temperature, what will be happening in the sense? It has some density reduction, which in the refractive index also reduced. Just for that, we made one design, one atom. So here, what will be happening in the sense? By increasing the salinity of the seawater, that is the sensor. So it is it is homogeneous sensor. I position it inside the water. The sensor is positioned inside the water. Then the light signal is applied. Then I got some signal at the output. After that, there is the signal conditioning. It is converted into the electrical signal. So based on the salinity, the electrical signal output intensity is varied, and the display will display whether the salinity is 50%, the salinity is 28%, the salinity is 40%. Here what will be happening? Based on the refractive index variation, based on the salinity level variation, the intensity, the output intensity is reduced. Otherwise, I can say that the output power is reduced. Next, you can see here, it is in deeper level. So, if the salinity level 0, you can get maximum output. The increasing in the water till 100% because of higher salinity, the refractive index keep on higher. Because of the higher refractive index, the propagation velocity of light signal is getting reduced. So, in my sensor, what will be happening? The intensity is minimized. By having the lookup table with respect to the what is the intensity, what is the salinity level, the display will give your water, your salinity water having 100% of salinity. In this way, the photonic sensor is going to work. Here I have shown only intensity reduction scheme. And there is another possibility, wavelength shift scheme. But at zero salinity, the wavelength may be 50 nanometer. 25% of salinity, it may be 50-60 nanometer. By identifying intensity variation and resonant wavelength shift, we can identify what is the sensing value from the sensor. This is about photonic sensor. Okay. Likewise, almost all the possibility, refractive index sensing and a body sugar level sensing, stress sensing, strain, both real-time application as well as medical application, it is possible. So that is the reason, recent days, that IoT application they are talking about optical based sensor, photonics based sensor. It will give a most accurate result with very short span of time. This is about photonic sensor. Now please, if there are any clarifications.
Here, it's about homogeneous sensors. So it is any particular solution you can use it in service. So I think this particular homogeneous sensors also inside of the for brain application.
Homogeneous, yes, we may use, but it is very difficult. Why? Because homogeneous, you should be positioned inside the measure. It requires higher amount of measuring value. Rather, if you select surface sensing, smaller amount of particle is highly sufficient. Just to keep in mind, that is one test to the measure. That is actually the surface sensing. TD part is highly sufficient. And the output, there is not much weight in the output.
Any other side effects will be there for the
In
human?
this way, we have to work with material science engineer. Material science engineer only you can use material A, material B composition. It will not give any side effect to the human body. Then only the IoT sensor, what we are discussing, IoT sensor inside the body, it is possible. If you feel that it is harmful, then it is very, very difficult. And for your kind of information, 2G and 3G, people talking about that cell phone tower radiation and cell phone radiation. For 4G and 5G, they are not talking about. The problem is, the thing is, they have adopted more number of antennas, more number of cells. You can see many number of antennas and cell phone towers are available. The thing is, if frequency is much higher, it cannot travel longer distance. Why? Because it carries minute amount of information. The bandwidth is also much higher. So, it travels only shorter distance all over. So, more number of antenna is required. So, the launching power is very, very smaller. That is the reason behind it, even in 4G and already in 5G also, they never talked about radiation effect for humans in the case of 4G and 5G. During the inception of 5G technology at US, initially they talked about it gives some strong signal. It gives some strong signal to the ATC, that is air traffic control. Which is related to the airport. So 5G signal is closely related to the airport signal. Thereby, the flight pilot may get wrong information or they may not get the information. It creates a problem. That is the initial task. Immediately, the problem is resolved by altering the frequency. Now there is no problem as far as the technical reports say. Okay, please.
Actually, we will tell that if it is more high frequency, it will be traveling to the long distance. You are saying that it is
See, high frequency very simple. I can show this part a bit longer distance. However, otherwise I can say there is one small stone, but very big stone. Small stone having the lower weight, that is called lower frequency. I can keep in my hand, I can travel longer distance. That's about the lower frequency. Why? Because the weight is less. Why? Because the bandwidth is less and the number of users is also less. What is the reason behind they are going for higher frequency in the sense? Like very big stone, I cannot travel longer distance. Why? Because I have many number of data, many number of users. Low frequency can travel longer distance. That is the reason behind it. Even in the case of 1G or FM, we have restricted industrial music for FM station or cell phone station. Nowadays, 4G, the data rate is it cannot travel longer distance. Similarly, in the case of 5G, it supports much data rate, so it can travel very shorter distance. That is the reason they have not increased many number of antennas. Why? Because for high frequency applications, the frequency is higher and the antenna size is lower. The frequency is higher, antenna size is lower. So you see, FM you can get very big tower. Okay, for cell phone you can see there are very small. I saw from Tirupati to college, I saw some round shaped cell phone tower and tube based cell phone tower. I don't know whether it is there. If it is possible, just you go upstairs and just you roam around, you can see cell phone tower where you can see some round shaped cell phone, round shaped antenna and another one tube based antenna. Okay, where the round side, the circular base is responsible to provide communication for short distance application. And the duplicate based antenna, it is positioned 120 degree at corner. It is responsible to provide service to the longer customers. It will be there 3G antenna and some more 4G. It is not possible, it is not necessary to have both circular shaped antenna and the tube-based based antenna. The thing is, the distance covered is the short distance and many number of antennas are required and it will cover very short distance only. Okay, it's very interesting topic. You can take a look on 5G technology and 6G technology. It's very interesting technology. Very interesting topic. Any other clarifications? Yes. Yes.
Go for materials.
Materials engineering.
Material. So we have to get suggestion first from them.
Yes.
Then only we can know that which sensor we have to use with the.
Otherwise, material engineering, even CSIR recently for all CSIR lab, Dr. Kalai Shalvi from Part2, she is from Tamil Nadu, she is heading that. Earlier, she was centered at CSIR Part2. Now, she is the overall head. They are doing lot of research on material engineering. So, whether this material can be suitable for industrial application, it can be suitable for medical applications. Medical application in the sense, it will not give any impact to the human body. Okay. So, from their point of view, we can collect what is the refractive index. So, to get at some refractive index, what are the compositions that the material engineer should give to us? Accordingly, we have to decide and we can go for application. And also, we straight away we cannot claim that I need this refractive index. You have to give a refractive index. I am going to implement in the human body. We can't say that. Okay, we have to get for medical application. We need to get proper material with proper certification. Then only we can go for it. But it is possible. Material engineering is emerging nowadays. It It is possible. You see, madam, probably in the year of 2035 to 2040, we may keep some sensor in our body. We may keep some sensor in our body. Definitely, by the time you recollect on the day Dr. Robinson mentioned about, definitely we are going to keep many sensors. Nowadays, culture is completely changing. See, in olden days, we are studying doing engineering studies. We know teacher is there, student is there. We have some guidance. Teacher has some guidance. We have some gap, and we know some materials. Nowadays, even LKG, UKG student, teachers send a message through WhatsApp. Homework filling through WhatsApp. I asked my children, don't use WhatsApp. He said, what shall I do? Madam is sending message through WhatsApp. And further, nowadays he is not typing the message, simply voice message. Simply voice message. Dear parents, do the homework of your children. Can you ask your children to do the homework? That's the real situation. That's the reason from the inauguration just we have discussed about AI for education. AI for education. Nowadays, AI is going to take a role. AI will arrange. See, there is a very big competition. You can, there is one book, is the homework. If there is any possible that you can get book review. Homework. HEMODUES. What is the prediction for 21st century? They are talking a lot. Human will not compete AI plus robotics. Very simple. AI plus robotics is called as human, right? I mean our parts, our activity, that is called robotics. Our intellect, our mindset, our creativity, that is actually the artificial intelligence. The thing is, we may forget. Suppose I am asking one, what's your name? What's your name? So next year or subsequent year, just there is a possibility and there is the opportunity to meet her. I cannot recollect what's her name, but AI will not do it. Correctly, I will say, hi, how are you? Where are you? On the time I met you. It will collect all the data from the database within the fraction of a second and it will give. One more thing, I mean, you watched many movies. There, initially, we feed some information to AI or AI-based devices.
The primary data also we should give to, sir.
Yes. And what will be happening if it is right? Okay, even if it is wrong, it will inform to the the opponent. And if the opponent is giving correct answer, it will collect, it will process. If next person will ask the same question, it will give other option, other answer. Even in the classroom, just simply asking what's memory transistor. A girl one may give answer A, and teacher is telling that no, your answer is wrong. And we are asking the question to the she is giving the answer is right. What the AI will do is, it will collect the correct answer, it will reproduce the correct answer. That is the beauty of AI. And one more thing, mostly probably is a beauty. That is the most important for all, even for teachers and for students. If any doubt, just simply, I don't know what is simple photonic sensor, go to YouTube, type photonic sensor working principle, that's all. Inverse sensor, what are the material compounds, either Google or we rely on YouTube. Very simple. See, I am wondering that usually morning we are having the habit to hear some devotional songs. Evening we may share, at night time we may have some melody songs. And morning we may watch videos, motivational videos. You see the one day, tomorrow morning at the same time you can see similar kind of videos will be displayed in your list. It's all here. So that's the reason. It is predicted that if we are entering into that book, if we are entering any shop to purchase our dress, it collects already many data. We are going one showroom. I need this dress, I need this kind of dress. One fine morning, AI will welcome you. Please, madam, please come. We are having this much collection. All the collection, this color only will match you. Better you go this section, you collect the dress, it is good for you. It is one step ahead, like a boy See, based on your interest that I have collected the data from your cell phone, I think for you, your mindset, your interest, scale A will not okay, scale B will okay for you. This may be possible. Just read the book, it's amazing. Definitely, I believe that, I feel that it may be possible. It may be possible. The thing is, it is possible, then only the prediction is given. Once the prediction is given, people will try to get into the reality. That is also possible. So this is about the development of AI. In my opinion, after reading that book, immediately I have to join one AI-based course. I want to develop AI-based knowledge. The job market is enormous for AI. I advise all, though we are electronics engineer, computer science engineer, or mechanical engineer, AI is unavoidable problem. Otherwise, a student will overcome. There will be a lot of projects related to AI. There are a lot of projects related to AI. This is about some AI conversion. So let's come back to the photonic based discussion. If you have any further clarification, please share. Otherwise, there are around some 10 more minutes. I'll discuss other challenge. First thing, I have mentioned about the fabrication. Fabrication is very, very challenging. Second one, we know that the core diameter of single mode fiber is 9 micrometer. We are discussing here the overall dimension is 5 micrometer or 6 micrometer or 10 micrometer. We have to couple the signal from single mode fiber and laser output unit to the device, then only the device will work. That is the next very big challenging task. For that, the tapering mechanism is available. So by having the proper tapering mechanism, so we can couple the light signal from single mode fiber or laser diode to the photonic crystal based sensor, or the sensor may be battery operated, or it may be operated by any other thing. We need to identify the right solution to feed the input signal. These are all challenges. However, the work is progressing, the work is going on, but we need to account the tapering mechanism as well as the fabrication. And in Columbia University, I think many people will know about Dr. R.S. Basically, sir is from IIT in Delhi. At present, he is working at editing scholar Dr. Rajesh. He worked. We tried to fabricate the chip in India. However, because of some other limitation, we tried to fabricate at Columbia University. They are asked 6 lakhs rupees for fabrication. You see the chip, I can't see, but they are asked 6 lakhs rupees. And next thing, interesting factor, I will give the chip, but I am not guaranteed whether you will get the output or not. Second check. Okay, sir. First, I can't see the chip, but telling that 6 lakhs rupees, okay, ready. Second option, I am telling that I am not sure whether the output will come or not. The thing is, that much amount of application complexity is there. But it is possible, recently it is possible. In ISC Bangalore, they have fabricated one chip. They have not a characteristics that may be solved very soon. I want I don't know solve. We work a lot. There are questions I think in Google you get many results.
So recently I studied gel-based sensors. Gel-based sensors.
Gel?
Gel-based
Gel-based
sensors.
sensor. Oh, okay.
So what's the difference between this photonic crystal and gel-based?
I have not come across what actually is gel-based sensor.
Gel-based.
Yeah, gel-based sensor. If I know, then I can really come back. I have not. See, I'll give some idea. This is about photonic crystal. By having this photonic crystal, almost all possibility can design, all the devices can design. Basically, this is normal structure and PPG, just I wanted to say. And this is three-dimensional view. Three-dimensional view, how it's supposed to. And after reflecting, whatever the wavelength, and we can get the response from this wavelength or some scan. It will take a week to get this simple response. It will take minimum of a week. The simulation time is much higher. And periodicity is also possible. There are many things. Like optical devices, for the teachers, if you are interested to do research, you can start design, that is combinational device or sequential devices, the digital logic devices, binary gray encoder, flip-flop, logic gates, encoder, demultiplexer, power splitter, filters, and laser, amplifiers. Likewise, you can design many components using photonic crystal. One thing you have to keep in your mind, the device dimension is very, very small. Device dimension is very, very small. The thing is, these are all the components that are required for photonic integrated circuits. This is about power splitter, filter. You can get this kind of batteries, how they have created the device, what is the resistance, band-pass filter, demultiplexer, duplexer. And also they have incorporated that antenna concept. It is actually the fractal structures. They have incorporated antenna structure also. Antenna concept. This is the end. How the fabricated structures. It's normal, only one line wavelength, line different introduced. Here, point different is introduced. Here is the bend. So normal conventional microwave or optical science, at the end, at this part, there is the possibility of scattering. The signal will go and try to touch in this signal. Some part of the signal will be reflected back. Here, what is the beauty is there? Though it is touched, it will turn this direction. It will turn this direction. The reflection is very, very smaller. Why? Because it is arranged very smaller distance in terms of nanometer. Hence, it can give 100% of what is the input signal that we are giving? It gives 100% of transmission. And it's new concept from the SRM University. Then hybrid, it is also new concept. And this is what I want to say. Taper to couple the signal from single mode fiber into the device. Then only it can that. Otherwise, it's very, very difficult. So there are three tapering: one rectangular tapering, and triangular tapering, and butt tapering. So, in my advice, for anybody working, even in sensor, you can use this rectangular taper. Thereby, the signal from single mode fiber will be coupled, which in turn it will be coupled with your structure. You can get the output response. And fabrication, conventional lithographic techniques already is there. One thing, IIT Bangalore, they have used AZ-S1813 photoresist for photoresist fabrication. Remaining all the technique are remaining for fabrication. So as far as photonic crystal with India is concerned, there is a possibility for fabrication. However, for characterization to measure the output response of the device, it's not yet. They are working on it. It's not yet. Okay. There are loss mechanisms. It is unavoidable. Both structure, one incorporated in the structure. So I can give some of the future research area. Machine learning, deep learning for PC as per our discussion. Optical device design as we listed. Fabrication, yes. then try to draw equal. It's not yet available in photonic crystal, and also to there is the calculation, the formula to identify the resonant wavelength is not yet implemented. You can work on it. Analytical modeling, real-time monitoring like photonic sensors, then network performance, all optical network performance, photonic antenna, terabyte applications for any kind. These are all future research areas. Is prominently available. You can take, if you are not doing research, you can take any one of the area and you can start your research in this area.
Sir, can you suggest any problems regarding why?
Yeah, for that I can't do public. Personally, I can give many kinds of problems. No problem, madam. Many numbers of problems are there. I can give you a lot. For software, you can use either ASAP full wave or bandsaw. So full wave, we have seen many responses, output response. You can get output response using full wave tool, and you can get the band diagram, PWE method, everything bandsaw. We are using full wave and bandsaw. Optical is there, numerical is there, crystal wave, MATLAB, you can work, but with complexity, meet console IPs. In my advice, better you can work with ASAP full wave and console. I think it's affordable cost only, just around 4 lakhs only. I think just you ask your institution that we can get it. Or else if you write the proposal, markup is open. As we are having MBA as well as NAC A+, definitely there is the possibility you can get it. We got it last year.
Excuse me, sir. Sir, by using the DCAT plasma, we can fabricate optical sensors and devices by using lithography techniques, sir.
Yes.
And directly we get the output and other characteristics.
Yes.
And based on that parameters and dimensions, we can fabricate that sensor physically.
Likewise, we have to fabricate. Physically, in the sense.
With the same, whatever parameters and dimensions we have used in the simulator, can we fabricate the
That's the
device
problem.
physically?
See, say for example, we are having the material dielectric constant is 3.46. So we need to get the approval from the material science engineer that material should not be harmful for human body. We have simulated, we got better output for 3.46 delta value. However, the material which is obtained from the material engineer, they have given the certificate, it is not at all useful for human body. It creates problem for your body. By the time we are not in a position to use or anything. However, for other applications we can use. For practical industry 4.0, IoT applications, medical application alone we need to get some permission. Other application, if it is not ready, by the time we can use, there is no problem.
But in simulator, whatever parameters we can adjust and we can fabricate the device, sir.
Yes,
Practically
definitely,
it is possible,
definitely.
or it can vary according to the.
Yes. See, we are having the material with the delta refractive index of 3.4. However, we are simulating the value with 3.46. Now we are having the available material. See, there is the material. Refractive index, we are having some slab. The refractive index is 3.4. However, we are simulating with 3.4. We are not getting the output. Again, we are doing some simulation by 3.46. We get perfect output, 100% transmission. Now there is a question. Material is not available, but output is coming at 3.46. What can we do? Simple. By adding components, by adding porosity, you can change the refractive index 3.4 to 3.46. So by increasing, by changing the value from 3.2 to 3.46, definitely it is possible to get 3.46. But we have to account other parameters where we are going to use, whether the material is going to radiate. Because of the radiation, the performance will be deteriorate, or we are going to incorporate our human body. Because of that radiation, whether human body will affect it, we have to issue other relay parameters, then we can use. Okay. And these are all some journals. Just we have before some journals only on photonic crystals. And this is the future. It composed of both one-dimensional, two-dimensional, three-dimensional. You see here one-dimensional, two-dimensional, and three-dimensional. It is the protection. With this, let me stop the photonic crystal morning discussion. Still, if there are any clarification, please. I have shared, we can talk a lot. I have shared based on the time, time is available. If you need clarification, otherwise, afternoon section we are going to talk about the paper writing, where we can. Okay. Thank you very much.
My break will be 1 to 2. Okay.
Lunch will be provided.
I'll just